Determine equation of the graph. So in this series I've got a couple of graphs which are all sinusoidal functions, and we'll learn how to write equation for the given trigonometric function, which is mainly sinusoidal function. Okay, so for all these graphs we'll use the general form of the equation, which is f of x equals to a times f of k times x minus p within bracket plus q. Here a is the amplitude of our sine function. Let's take sine as a default function, and k is the horizontal stretch or compression. It also tells you how many waves are there in a time period of 2 pi or 360 degrees. P is horizontal shift or a phase shift for the sine wave, and Q is the units by which the axis of symmetry moves up or down. Now, general formulas to find A, K and Q are: for A, how do we find A? We find A, the amplitude, from a graph by checking what's the maximum value and what's the minimum value, and then if we have maximum minus minimum divided by 2, we get the value of A. To find Q, we do Q equals to maximum plus minimum, that's the average value, right, divided by 2. And to find K, what do? We do K equals to, since this graph we have got 2 pi here, so we'll write 2 pi. Now by default one sine regular wave has got time period of 2 pi, right? So it is 2 pi by the time period of the given wave. That is how you get the K value for any graph, right? All these principles are general. And to find P, we really have to see, after drawing the axis of symmetry, from where the wave starts, right, the initial point, and how much it has shifted from its original position. Shifting right will give us a P positive value. So let's do it with an example here. Now there's a sine wave given to you. Now as you can see, let's write down what is the maximum of the sine wave. Maximum is 4, correct? So we'll write here maximum equals to 4 units. And what is the minimum? Minimum is minus 2. Say minimum is minus 2, correct? So we got maximum, minimum. Thereby we can calculate A, Q, right, both A and Q, which is the amplitude and translation of the axis of symmetry, correct? So let's do this. So A for us, the amplitude, is equals to 4 minus minus 2. So let me write 4 minus minus 2 divided by 2, correct? That means 4 plus 2 is 6, 6 divided by 2 is 3. So we get A as 3. So we can plug in 3 here, right? Q equals to 4 plus minus 2 divided by 2. 4 minus 2 is 2, 2 divided by 2 is 1, so we get Q here. At this stage, what we can do, and we should do, is we should draw our axis of symmetry. So at 1, we have axis of symmetry. So let's draw it. It's a good idea to draw axis of symmetry at this point. This gives us phase shift, right? We'll get into phase shift a bit later. First, let's figure out the time period. Okay. Now to find the time period, you can check distance between 2 maximums or 2 minimums, correct? Any good points will give you. So in this case, in this scale we have so many divisions for 2 pi. So let's count how many divisions give you 2 pi. So that's the axis: 1, 2, 3, 4, 5, 6, 7, 8. So 8 divisions are 2 pi. That means each division is pi by 8, right? So let me just write down here, each division here is pi by 8. just to remember. So we'll go by multiples of pi by 8. Now, so the time period for one wave is, let's check this wave out. So this wave is starting from this top and ends here. So it is pi by 8 each division. So 1 pi by 8, 2 pi by 8, 3 pi by 8, 4 pi by 8. You see that? That's how you can count, right? So we just counted this and we got this wave as 4 pi by 8. You can count from here also. 1 pi by 8, 2 pi by 8, 3 pi by 8 and 4 pi by 8. And therefore we say, well, the time period is 4 pi by 8. Since time period is 4 pi by 8, what is the value of k? So k is 2 pi divided by t or multiplied by 8 over 4 pi. Is that okay? Because 1 over t is 8 over 4 pi. So that is it. So that gives us the k value. So the k value is, I can simplify this and say 4 goes 2 times, pi and pi cancel out, right? So I get 4. So k is 4. You will note one more thing. Something is wrong. Now 4 pi by 8. Let me just check again. So each division is, okay, yeah, this is wrong. It is 2 pi by 8, not pi by 8, right? So we'll make a correction here, right? The correction is, and I'll tell you how I found that there is something wrong. Correction is like this. This was 2 pi divided into 8 equal parts. So it's not pi by 8, it is 2 pi by 8. Is it okay? Which is as good as pi by 4. Do you see that? So 2 pi by 8, which is pi by 4. So when we found the time period, it is 1 pi by 4, 2 pi by 4, 3 pi by 4, 4 pi by 4. Correct? Again, 1 pi by 4, 2 pi by 4, 3 and 4 pi by 4. So the time period is not 4 pi by 8, but 4 pi by 4. That means pi. So time period, so we'll just correct this, okay? So k is 2 pi by time period t, which is pi. And therefore k is 2. K is 2. Pi and pi will cancel out. Now, I'll tell you how I found, and that is how you can also correct. Now, when they say k is 2, it really means that within a period of 0 to 2 pi, we have two waves. Do you see that? One wave and the second wave. Correct? So we have two waves. So I was just counting the waves and found we don't have 4 waves, so there is a mistake. And we figured out, well, there are 8 divisions, but I needed to divide 2 pi by 8. I did a mistake. I did pi by 8. So now it is all correct. So k is 2 for us. Correct? So now you know these 3 things straight away. Now let's figure out the phase shift. Now phase shift is with respect to sine and with respect to cos. So we can actually write 2 different equations for the same function. Okay. Now if you see, that is our axis of symmetry which is drawn. So if you see at this point, it starts like a sine wave. So P for sine wave is 0. Do you see that? So I'll write this in a different ink so that you understand what I'm trying to say. So if I consider a sine wave, then P is 0, right? But how about the cos wave? For the cosine wave, what is the value of P? You see, the cosine wave actually doesn't start from here. It starts after the first division, and each division is pi by 4. So P is pi by 4 for the cosine wave in this case. Do you see that? So that is how we can find the phase shift for sine or cosine wave, right? Accordingly, we can write now 2 different equations which represent the same thing. Let me just divide this page like this. Now, my equations are, first, let me write for the sine wave. For sine wave, this function f of x is equal to, a is 3, right? So I'll write 3 for a. And the function I'm writing is sine. K value for me is 2. There are two waves in 2 pi. Do you see? One wave, second wave. Two waves. 2. X and P is 0 for me, so I'm just writing 2x. There was no need of this bracket at this time. And Q is plus 1. And you'll see this wave axis is 1 unit up, plus 1. So that is my sine wave. Okay. If I have to write the same function as cosine function, then I will write this as equal to, so I can write f of x is equals to 3 times cos 2. The thing changes phase shift. Sine and cosine are same waves with a shift in phase. X minus pi by 4. Do you see that? Plus 1. So, rest of the things remain same. So what really changes is phase shift for sine and cosine function. Do you see that? I hope you appreciate the whole process of doing it, right? And checking it back, we can check it back like this. Let's draw the axis of symmetry at 1, which is this line for us, right? Now from here, how much units do we go up? We go 1, 2, 3. That is the amplitude. Do you see that 3? So that's the check for amplitude. Now 2. 2 means from 0 to 2 pi, do we have two waves? That is a check. Yes, we do. One wave. Do you see one wave? This is one. And then we have the second one. Correct. So we have two waves. That is a check for the k equals to 2. Now for sine, starting at 0. Yes, starting when x is 0. Correct. 1 unit up. That is right. So our equations represent the graph. Perfect. Thank you.